Surface mapping will be the focus of this software highlight. When mapping with a confocal Raman microscope, the ideal scenario is that your sample will have a perfectly flat and smooth surface. This means that the sample will remain in focus throughout the entire measurement. As the laser moves to each XY point in the map, the laser will remain perfectly focused in the Z axis, and any resulting spectral variation shown in the Raman map can be attributed to differences within your sample. In reality, samples are not always going to be flat. They might have a rough surface or be tilted in nature, and as we Raman map these sample types, the laser will move in and out of focus. When the laser is in focus, the laser spot will be small and offer high Raman signal and high spatial resolution. When the laser is out of focus, Raman signal will be lowered and the spatial resolution is reduced. In this software highlight, the example we've chosen to discuss is a pharmaceutical tablet with a dip in the center. As we use standard mapping on this sample, Raman spectra are obtained from both the in and out of focus regions. We can clearly see from the white light image that the center of the tablet is not focused. The result of this is our Raman spectra will show significant differences in intensity when we measure these out of focus regions. In fact, in this sample, over half the Raman intensity is lost when we measure those out of focus Z points. The solution to deal with these sample types in Ramacle first builds a surface image. Far and near Z points are defined by the user based on their sample's lowest and highest points of focus. This range encompasses the total surface height variation. The user then defines their Z resolution, and a series of white light Z stack images are taken. For our pharmaceutical tablet, the height variation of the surface is 520 microns, and Z-stack images were taken every 20 microns. These Z-stack images are processed in Ramacle, creating one image that is optimally focused at all XY points. Ramacle now has the focus Z coordinates for every XY point stored, and we can view our surface image in 3D topography view. We can now move on to step 2, Raman mapping the surface, where the Z values that are needed are known from the surface image that we just built. At each XY map point, Ramacle will adjust the stage Z position, keeping the laser in perfect focus with the sample for the entire measurement. Whilst the map is being acquired, the surface image can be displayed in 2D or 3D, and the user can watch as their map is running. They can clearly observe that the sample is perfectly in focus, and all their Raman spectra will be taken at the correct Z point. We now have the final result, a fully focused Raman surface map, where the user can be confident that any spectral differences are due to true sample variation and not out of focus Raman measurements. For this sample, we can clearly see the shape of the surface, and the three components of the tablet are well resolved. We have paracetamol in blue, aspirin in coral, and caffeine is shown in green.